All right. Now, a periodic function, that just means it repeats infinite times following the same pattern. All right. So that's what a periodic function is. All right. And then a period is one cycle of the function. Okay. Okay, those like the amplitude, and that's what a periodic function is. And sine functions and cosine functions are periodic. Right? They're just gonna keep making those like kind of waves. And we use sine and cosine functions in the real world. You'll see them in music. See them in earthquakes. We talk about waves. Okay, things like that. All right. So the most common functions we're going to talk about, the parent functions of sine and cosine, y equals sine of x. Sorry.
The definition of cycle.
Definition of cycle. Oh, definition of cycle. I don't know why I have that on there. It's almost the same thing as like a period. It's like one cycle of the function. I don't know. That's just a terrible way of using. Let's use the word in the definition. That's terrible.
Is it like peak to trough?
Yeah, a cycle would actually be from peak to peak. Yeah. So a cycle is from peak to peak or trough to trough. All right, so that's what a cycle is. It's just following from one part where the function starts to another point where it starts again. So like with this sine function here, it starts going in a positive direction there. When it's going in a positive direction again, crossing the x-axis, that's where one cycle ends. Or you could say peak to peak, that's a little easier to recognize. Trough to trough is a little easier to recognize. All right, that's what we mean by one cycle of the function. Okay, so two functions we typically talk about, y equals sine of x, y equals cosine of x. These are just the parent functions. And they have specific things that are always true about them. The domain of each of these functions is always going to be all real numbers. We could say, let's do this properly, x is an element of all real numbers. Or if we did interval notation, we say negative infinity to positive infinity. You can put it in either notation you want. That's entirely up to you. All right. That's the domain of each parent function, if we were just to graph them. The range of each function, if I were to do set notation, it's going to be negative 1 is less than or equal to y is less than or equal to 1. Or interval notation goes from negative 1 to 1. All right, so the range always stays between those values of 1 and negative 1. Always, always, always. Okay. The maximum value of each function is 1, and the minimum value of each function is negative 1. And we want to identify the min and the max, so that way we can do the amplitude. The amplitude is the max minus the min divided by 2, which in this case is 1 minus negative 1 divided by 2. which just becomes 1 plus 1 divided by 2, which is 2 divided by 2, which is 1. All that fun stuff, just to say, hey, that's the amplitude. Another way to think about it is it's half. Like if you can find the midpoint of the graph, the amplitude is going to be from the midpoint to either the top or the midpoint to the bottom. Those are the easiest ways to think about it. All right. Each function is periodic, which means it's going to repeat. It's cyclical. It'll just do the same thing over and over again from left to right. Make that wave as it goes. Okay. We've got x-intercepts and y-intercepts for each function. The x-intercepts for y equals sine of x. So the first one's going to be at 0, 0. The next one's going to be at 180, 0. Then 360, 0. And dot, dot, dot. It's going to go every 180 degrees till the end of time. All right. And you could go negative direction as well. It could be negative 180, 0. All right. The x-intercepts for the cosine function are also going to go every 180 degrees, except they're going to be on the 90s. So 90, 0, 270, 0, 450, 0, is that right? Plus 180? Yeah. 450, 0, dot, dot, dot. Okay. Typically when we talk about it, we're just going to try and focus today on drawing one period of the function, so we don't need to worry about drawing much more than that. Y-intercept for sine of x. We already mentioned the y-intercept is going to be at 0, 0. There's only one y-intercept. The x-intercept, or the y-intercept for the cosine function is going to be at 0, 1. That's the y-intercept for the cosine function. Happens to be at the maximum value versus the intercept, the x-intercept. All right, those are the characteristics of sine of x and cosine of x. And when we start graphing these, hopefully it makes a little more sense to you. You might remember, it might come back to you from the last couple of years. All right. The one thing we want to focus on big time is transformations. Today we're just going to talk about vertical stretch and horizontal stretch, so keep it pretty simple. And whenever we're talking about these functions, I just want you to show you that the x-axis is always going to be, in this course, in degrees. So last year we would have dealt with radians for the x-axis. This year the x-axis is always going to be in degrees. All right, that's kind of nice. I like degrees a little more than radians. That makes a little sense to me. Radians aren't too bad in my opinion, but they can be tricky. So, all right, so now a vertical stretch, these are the transformations we could deal with sine of x and cosine of x. A vertical stretch is going to result in a change in amplitude. All right, so the amplitude of the parent function is always going to be 1, so it goes from 1 to negative 1. That's the max to the min. All right, so a vertical stretch is going to change the amplitude value. So in example 1 here, or example A, we see a 4 written in front of the sine of x here. That's just saying, hey, that's going to be our amplitude there. So amplitude is 4. A equals 4. All right, whatever number is in front of the sine or the cosine that's being multiplied by it, that's your amplitude. And that means we're stretching vertically. We're going to make this thing a little longer. A horizontal stretch is a change in the period of the function. So that's going to stretch it to make it the period change a little longer. Okay? All right. So whenever we're looking for the amplitude, we can say the amplitude equals the A value. So we can just say amplitude equals A. And the period, the way we calculate the period of a function is we use the b value, but unfortunately it's not just a simple saying b. It's going to be 360 divided by b. So we're taking, because the normal period of a function is going to be 360 degrees. And think about, like, if you're on a circle and you rotate around, like yesterday we talked about the standard position angles from the positive x-axis, and you rotate around 360 degrees to complete a full circle. That's why it's one period of the function. So when we add a b value, like down here, we just need to say, find the period. Let's do 360 divided by that 4. So the period in example B is 90, okay, instead of 360. Whenever we want to graph these functions, we're going to want to focus on 5 key points. All right, 5 key points. So I've just got a little graph here, and I'm going to go put 4 tick marks along it, because the first one's going to be right at the intercept here. And basically I'm going to split it into fourths. So there's 1/4, 2/4, 3/4, 4/4 across. I'm going to do that on the next one too. Because when I split it into fourths, I can sketch one period of the function every single time once I have all the information. So the first problem, we'll start with the amplitude was a equals 4. The period was 360 degrees. It wasn't affected at all. So what I'm going to do is I'm going to start this graph at 0 degrees, and I'm going to end it at 360 degrees. That's one period of the function. The amplitude is 4, so I'm going to make my maximum 4, and I'm going to make my minimum -4. I'm just trying to sketch the exact graph every single time. So let me start by showing you this. What we're really doing on these types of problems, I'll switch my screen in just a second here. Hey, this is a sine function. The sine function is always going to look like this. It's going to go from 0 down to up to its maximum, down to its minimum, back up to 0. Sine function's always going to look like that every single time. And I'm going to build the viewing window around that. Cosine function, that's part B, that one starts at the maximum, goes down to the minimum, and back up to the maximum. So without labeling the graph yet, I know what my pictures are going to look like. That's really the goal for today. I just want to capture one period of the function. With my sine function, we already said we're splitting this into like fourths. So half of 360 is 180. 1/4 of 360 is 90. 3/4 of 360 is 270. And that's kind of what I have written up here as well. So it says like 3/4 times 360 over b. And then 1/2 times 360 over b. 360 over b is the period of the function. So that's what these numbers mean. And this one's labeled actually 0, 90, 180, 270, 360. I didn't do a good job of killing my labels there, but that's fine. That's just supposed to be a generic look. Okay, so now once I have those labeled, I have my maximum labeled, my minimum labeled, and I've got my points labeled across. Now I can identify what are my intercepts. I've got 3 intercepts. I got one there, and one there on this drawing. So I want to label those 3 intercepts. There's one at 0, 0. There's one at 180, 0. And there's one at 360, 0. And then I want to label my maximum. My maximum happens to be at 90, 4. And then label my minimum. My minimum happens to be at 270, -4. This is why I said there are 5 key points. Oops. Because when I'm done with my graph, I should have 5 points here. 1, 2, 3, 4, 5. 1, 2, 3, 4. 5 points that are going to help me sketch the graph. My cosine function is also going to have 5 points. It's got the maximum, the 0, the minimum, the 0, the maximum. So it's going to have 2 maximums and 2 zeros instead of 3 maximums and instead of 3 intercepts and 1 maximum. But it's still going to have 5 points total. With the cosine function, I know the amplitude is 1. There's no value in front of the cosine. So this goes from 1 to -1. I know this period is 90, so this is going to end at 90 degrees. So I'm going to have to split this into fourths now. 90 divided by 2, that's an easy one, that's 45. But 90 divided by 4, or 1/4 of 90, that gets me over here, that comes out to like 22.5. And then 3/4 of 90 comes out to, what was that, 67.5. So they're not pretty numbers, but that's what these intercepts will look like for these values. So my intercepts, 22.5 comma 0, 67.5 comma 0. I'm only drawing one period of the function right now. I put arrows on it because it does go on forever in both directions. It's going to be periodic, but I only want to label these 5 key points for one period of the function. My maximum, or maximums in this case, there are 2 of them, happen to be at 0, 1 and 90, 1. My minimum, there's only 1, happens to be at 45, -1. That's how I identified those 5 key points here for these types of values. Okay. All right, and that pretty much covers what we need to talk about today. Very short lesson, and I gave you a short lesson on purpose because I want you guys to have time to do this assignment, and I also want you guys, if you wanted to, you could work on the other lesson today as well. The other lesson is just diving into the book and it's giving you these types of problems as well. On your assignment tonight, I've got the answers posted here, but I've got it on the answer key as well, so I don't need you to copy them down. But literally, cosine function, draw a cosine function, and then label the graph around it. Sine function, label the graph around it. Draw the sine function, label the graph around it. That's what I want you to do on these types of problems. So there's 6 of them to practice, and then there's 3 problems where I give you a graph, and I want you to identify the amplitude and the period based on the graph. So look from peak to peak or trough to trough, whatever helps you identify those values. All right, so the assignment is posted. The answer